Welcome everyone to Teachita FluidSIM series. In this video, we are going to cover time delay valve. As you might remember, in previous videos, we discussed directional control valves. We covered shuttle valve and twin pressure valve. We also looked at displacement step diagram and the case of signal overlapping. And in addition, we covered different forms of actuation and basically actuators like single acting cylinder and double acting cylinder. This video, as I said initially, is going to be about time delay valve. So without further ado, let's focus on time delay valve and see how it functions within a pneumatic circuit. So as the name shows, basically time delay valve provides a time delay for a certain functionality within a pneumatic circuit, and it is basically categorized as combinational valve. What do we mean by combinational valve? Basically, we can make certain functionality with combining different components within pneumatic circuit. For example, in time delay valve, we use 3x2 way valve, one-way flow control valve, or throttle check valve, and air reservoir in order to provide a certain amount of delay within a pneumatic circuit. So in general, we can have two forms of time delay valve depending on the directional control valve that we have within that time delay valve. It can be in the form of normal, open position condition, and also closed condition. So we can have directional control valve with normally open position or normally closed position, and from there we can have time delay valve with the same functionality. In general, the delay time for time delay valve is between 0 to 30 seconds, but we can basically change it a bit with adding extra reservoir inside the pneumatic circuit to basically increase the amount of delay needed for a certain application. And now let's look how a time delay valve operates. As you can see in here, let me bring the laser pointer. As you can see in here, we have the symbol of time delay valve. So whenever you see this symbol, it means we have a time delay valve within that pneumatic circuit. And here we have throttle check valve. We already discussed how a throttle check valve works. We have a reservoir, and we have basically a directional control valve. If we look at directional control valve, we see it is basically in the form of normally closed condition, which means if we bring the air from port 1, it cannot reach to the actuator connected to this port 2, right? So the air cannot pass through this directional control valve. And as you can see in this side, we have a form of pneumatic actuation from left side, and we have a form of a spring return. So in order to have this directional control valve in an operational mode, what we need to have first is basically pneumatically actuate this directional control valve. And now how we can pneumatically actuate this directional control valve? We have a port which is called number 12, and we have a port which is called number 1 in here, right? Port number 1 is directly connected to this directional control valve, and it is basically providing the air from the supply element, right? It has the compressed air, but that compressed air is blocked here. Now, if we look at number 12, right, the downstream of this number 12 is also connected to air supply, and it is providing basically the compressed air, right? So if the air is coming from this side, you see we have a throttle check valve here, right? The air coming here, and first it want to pass through this line, but because this ball is going to cover this edge, right, the air cannot pass through this way, right? So the only way that the air can reach to this pneumatic actuation is this throttle, right? Depending on how much opening that we have for this throttle, we can basically control the flow rate, right? And at the same time, depending on the volume of this reservoir, we are basically providing the air for that reservoir, right? When the air is passing through this throttle check valve, it reaches to this point, and first it should fill this reservoir, and once that reservoir is completely filled, right, the air can reach to this pneumatic actuation, and from there we pneumatically actuate this directional control valve. So if we look at this symbol, and if we look at this time delay valve in here, we'll see there are two important points and two important factors in here. Depending upon the opening level of this throttle check valve, and depending upon on the volume of this reservoir, we can apply a certain amount of delay to this directional control valve, and at the end to the system that we are working with, right? So basically the delay in the system is coming from these two components, and now when we pass that amount of delay, this is going to be actuated, and we'll get to the second position of this directional control valve. Right now we are in the second position. The air can pass through this arrow, and from this arrow air gets to the port 2, right? And if that port is connected to an actuator or another directional control valve, that will be actuated. It can be in the form of retraction for a directional control valve which is connected to an actuator, or it can be a starting point. So it is again completely related to the application that we are focusing on. Okay, so now let's say we have the time delay passed, right? The system should return back to its initial position, right? Because we applied the delay, the pneumatic actuation actuated the directional control valve. We had the directional control valve in its second position. Now let's assume the delay is gone, the actuation is gone. Basically, the directional control valve should return to its initial position, and as we have a spring return, the spring should return it to its initial position, should return that directional control valve to its initial position. What will happen first, because we have the air inside the reservoir, the air from that reservoir, right, will pass through this way because it is basically a free pass, right? And once the full amount of air is passed through this line, the next point is getting back to the initial position, and once it is returned back to its initial position, the air will pass through line 2 to line 3, which is the exhaust. So that is how a time delay, which is normally closed, as you can see in here for this specific case, operate inside a pneumatic circuit. Now let's look at one example, one practical application. First, I'll cover this example, and then we will look at one practice problem, and I'll basically provide the FluidSIM circuit of that one inside FluidSIM software, and at the same time we'll practice the concept of time delay valve, and we'll understand how time delay valve functions inside a pneumatic circuit, and also we basically practice inside FluidSIM to see how we can basically design a pneumatic circuit with a time delay valve inside FluidSIM. One practical case is, let's say we have a double acting cylinder, and the double acting cylinder is used to press two components together. Generally, when we are pressing components together, we need to have a certain amount of delay when basically we are in the advanced condition and two components are completely attached together, because that is helping us to make a bit of better pressing in that certain condition. Once the push button, let's look at the steps here. Once the push button is actuated, the clamping cylinder is extended. Once it reaches its fully extended position, the cylinder must remain idle for 10 seconds and then immediately retract to its initial position. And again, if we look at here, the cylinder must remain idle, which means we have a certain amount of delay, and that delay is specified, which is 10 seconds, and after 10 seconds it should immediately return back to its initial position. So that is the delay. And if you see a problem like this, you need to put a certain amount of delay, right? And therefore you need to have a time delay valve. After the cylinder reaches to its initial position, it remains there for 20 seconds. It means we have another time delay valve. The system operates based on using two time delay valves in two different conditions. During this delay, the pressed part will be removed. So we are giving a certain amount of time, probably to another actuator, which will push basically this pressed part inside another place, right? So that is how this system functions. First, we need that delay, right, for pressing, and then we need another delay in order to have another basically actuation mechanism which push that components, that press components, inside, let's say, an outfit chute, right? So that is how time delay valve can help us inside a pneumatic circuit or for a practical application. Now let's look at the example that I plan to solve it inside FluidSIM, and I want to design the circuit inside the FluidSIM. So what we have in here, we have a double acting cylinder, and it is used to press together glued components. Upon operation of a push button, the clamping cylinder extends. Once the fully advanced position is reached, the cylinder is to remain for a few seconds and then immediately retracts to its initial position. The cylinder retraction speed is to be adjustable. A new start of the cycle is only possible after the cylinder has fully retracted. So there are a few important points in this problem statement. First thing that we have a double acting cylinder. So the form of actuation is a double acting cylinder, and it is used for pressing, right? For pressing together basically two glued components, right? And once we push a button, so we have to use a push button, the clamping cylinder extends. So the first thing is we have a push button, and whenever we touch that push button and we push it, basically the cycle is started. Once the fully advanced position is reached, the cylinder is to remain for a few seconds. That is a very important point, which means we have a sort of time delay in the system, right? Basically, that is where we have to use the time delay valve, right? And then immediately retract to its initial position. So, which means whenever the time delay is gone, right? And once we have that actuation for the retraction, the time delay valve should return back to its initial position, and the system should retract to its initial position very quickly. Actually, that actuator should retract to its initial position very quickly, right? And it says the cylinder retraction speed is to be adjustable. It reminds us a form of basically speed control, right? We need to have throttle check valve, as we already discussed. Throttle check valve is used to control the speed, right? So we can put a throttle check valve and control the speed of basically actuation and retraction. And finally, it says a new start cycle is only possible after the cylinder has fully retracted. What it means, basically, we have to look at the position of the piston inside the double acting cylinder, and we should have a sort of checking, right? Once it reaches to basically the fully retracted position, we have to inform the system, okay, we are in a fully retracted position. Therefore, we have a sort of basically linking between the position and another directional control valve within the pneumatic circuit, right? And from there, that pneumatic circuit probably is connected to a sort of twin pressure valve, right? And as you know, twin pressure valve needs to be actuated from both sides, right? When it reaches to fully retracted position, we have one side of that twin pressure valve in the form of actuation and the other side is not actuated, which means we have a push button over there which can basically provide the air for the other inlet of the twin pressure valve, and from there basically we can start a new cycle. that is completely clear, because if we look, we basically from the problem, we need to have a double acting cylinder, we need to have a push button, right? Directional control valve with a push button. We need to have a time delay valve for the retraction process, and also we need to have a twin pressure valve for basically checking, right? So without further ado, let's start designing the circuit inside FluidSIM. As we discussed and as we saw in the problem, for this one, we are looking for basically a pressing system, right? And we have a double acting cylinder. And when this double acting cylinder is in fully advanced position, basically it is pressing two glued components, right? And at that specific time, we need to have a certain amount of delay, which means we need a sort of time delay valve in here in order to apply that delay. The other thing that we need for this circuit is basically throttle check valve, because the problem is saying that the speed of retraction should be adjustable. So we need to have throttle check valve within this circuit. And another condition that should be met is basically related to starting of the cycle, right? When the circuit reaches to the initial position, right, we should have a sort of let's say verification or confirmation over there to ensure that the circuit is at that specific location, and basically the piston inside the double acting cylinder is in that certain position. So in order to have that check, we need to have a sort of linking between the double acting cylinder and the directional control valve that we are using in the system, and at the same time we need to have a twin pressure valve within the circuit. So these are a few main components that we can basically understand from the problem statement that should be used within this pneumatic circuit. So without further ado, let's bring all components needed for this problem. The first thing that I'm going to bring is the double acting cylinder, right? We need to have a double acting cylinder for the actuation, as the problem says. The other thing that we need to bring in here is basically the supply element. So I'm going to bring the supply element here, and a manifold basically for distributing the air, and air service unit for air filtration, right? So these are the main three components for air supply, air service unit, manifold, and one actuator on top, as we can see. Then we need to bring throttle check valves before actuation, before the actuators. So I'm going to bring the throttle check valves. So we need two of them. The first thing that I'm going to do is basically provide the arrangement needed for this circuit and for this throttle check valve here. So we need to rotate it with 180 degrees and then mirror it horizontally. Now we have the throttle check valve ready. We can basically bring the other one. We need two of them, as you see in here. Now we can connect them to the basically the actuators. Now they're connected to the actuators. The next step in here is bringing the directional control valve. We need to have a directional control valve with 5-way 2 positions before the throttle check valve, and it should be pneumatically actuated from both sides. So let's bring that directional control valve. I'm going to choose the configurable one, so this one, which has 5-way and 2 positions. And the other thing that I need to bring in here is 3 directional control valve. 2 of them are going to be connected to a twin pressure valve, and the other one is going to be connected to a time delay valve. So let me bring all of them here, right? And this is the third one. And also we need to have a time delay valve, because the problem is saying we need to apply a certain amount of delay once the double acting cylinder reaches to fully advanced position. So in order to find the basically time delay valve, we need to look at the valve groups, because it's a sort of combination of valves, right? And based on the given statement inside the problem, we need to have a normally closed time delay valve, because it is going to stay for a certain amount of time, right, without providing the air to the actuation mechanism for the directional control valve, and from there for the double acting cylinder. Therefore, it's a normally closed time delay valve. So this is the normally closed time delay valve that I'm bringing here, and now we have almost everything ready. Just one thing left, which is the twin pressure valve, and the twin pressure valve is located in flow control valves, and this is going to be at the end connected to this two directional control valve. Now we have everything almost ready. Here is time to connect different components. I'm going to start with the air supply connected to this air service unit, and then the air service unit is going to be connected to the manifold, as you can see here. And once I connected this to the manifold, it's time to connect it to the directional control valve. So this is going to be the first one that I'm going to connect, right? And then we need to connect the other one, which is this one, right? Now we have both connected. The next step is basically configuring these two directional control valves. So the first one is going to be basically the starting point for us, and it's going to be in the sort of a push button, as the problem says. So we have to look at the manual actuation. I'm going to choose the push button, and it's a spring return, right? And I'm going to label it as 1S1 and hit OK. And the second one, we need to basically put the exhaust too. So putting the exhaust. And the second one, as you can see in here, is going to be a sort of directional control valve, but this is going to be connected to the position of basically double acting cylinder, and it is going to provide the confirmation of the position for the double acting cylinder when it reaches to the fully retracted position. So I'm going to use a mechanical actuation and a sort of roller valve. So this is going to be the mechanical actuation, and the other side is going to be a spring return, and I'm going to call it 1S2. So this is the second one that we have in here, and hit OK and putting the exhaust, right? Now it's time to basically connect it to the twin pressure valve in here. So this is the first one, this is the second one, and now we can connect this twin pressure valve to this directional control valve that we have in here. So this directional control valve, as I said, is going to be pneumatically actuated from both sides. So we have to choose pneumatic actuation for the left, pneumatic actuation from right, and I'm going to call it 1V3 and hit OK. And this is going to be connected here, right? And we can connect these two ports to the throttle check valves that we have. Okay, now we have every connection needed for this side, right? And the other thing that we need to do is just connecting this one to the manifold and the exhaust, right? This side, and the other exhaust this side. Okay, so almost this side, the left side of the circuit is ready. It's time to look at to the right side, in which we have basically the time delay. And as you can see, before that we have a directional control valve, and this directional control valve is going to be connected to the fully advanced position of this double acting cylinder, right? So again, I'm going to use a sort of mechanical actuation, the roller type, a spring return, hit OK, and I'm going to connect this side to here, and this is going to be a sort of exhaust, hit OK. Right, now we have the connection ready for this one. I'm going to call it 1S3, and this is going to be connected to the port 12, right? And the other side from here, I'm going to connect it basically the manifold. Another port is going to be connected to the directional control valve, so the pressure port of the directional control valve. Now the directional control valve is ready in terms of supply. It should be connected to this pneumatic actuation for this directional control valve, and I'm going to call it 1V2. Okay, 1V2 and hit OK. And we are good in terms of labeling for, sorry, it should be 1, yes, it is 1v2, this should be 1v1. So we are good in terms of labeling for these components. We can jump to the throttle check valves, right? So we can basically change this throttle check valve name to 1v4, and the other one is going to be 1v5, right? With the use of these two throttle check valves, we have the capability of adjusting the speed of basically the actuation, the actuators, the piston of the actuators, and from there we can have different speed for the retraction and advance, and then hit OK. And for this one I'm going to put 1A, but the important point about it is basically the actuating labels. So for the initial point, basically when it is in fully retracted position, it is connected to 1s2, so the starting point is going to be 0, right? 0 millimeters, and we already considered 100 millimeter as the maximum stroke. So when it reaches to fully advanced position, it means it is in the maximum stroke, which is 100 millimeters, and it is going to be connected to 1s3. So I'm going to put 1s3 here and 100 millimeters, and then hit OK. Now at the initial position, it is connected to 1s2. When it reaches to fully advanced position, it will be linked to 1s3, and that is going to be actuated. Now every actuations needed, every linking connection in here is ready, but we have to look at the time delay that we want to put in. We are looking for a few seconds, and in order to adjust the amount of time delay that we want for a certain application is completely related to the reservoir, completely related to basically the opening level that we have over there. So what we can do easily, basically just double click in here, you can see we have the flow control valve, which is basically providing the opening level. We can see the volume of the reservoir, right? How much is the volume and how much air can be supplied over there, and how much air is needed for basically the full capacity of that reservoir. And we can see the directional control valve, the nominal flow rate for it, right? So what I'm going to do in here is basically changing the reservoir in here, the volume of that, to 1, because when we choose 1, we basically changing because you see that nominal flow rate over there is 10, right? And when that reservoir has the volume of 1, it takes a bit, let's say a few seconds, to basically fill that reservoir, and from there we have a certain amount of time different, right? So I'm just going to choose 1, and then when we have this one, it takes a bit to basically fill that reservoir, and from there, right, we would have the retraction procedure. Now everything is ready. Let's start. OK, and let's start the simulation. Okay, so I'm going to start the simulation. As you can see, the air is in there, right? Because we have the manifold. The manifold is distributing the air between different components. Air is blocked here, but this one is because in the initial position, this is in actuation mode, right? In the second position, the air can pass, and this twin pressure valve is waiting for the push button for an operator to push this button. From there, we can have the air passing through this line, and both conditions are in true cases, right? We have a twin pressure valve, and it needs to have the air from both sides in order to send the signal to the next component. If we push this button, we basically get that situation, and the air will pass to this directional control valve, and it starts actuating this double acting cylinder. Depending on how much opening level we have in this side or this side, the speed of the basically advancing and the speed of retraction will be different. Let's look at this side. As you can see, the air is blocked in here because it is a normally closed condition, and the same thing is happening to this time delay valve, right? When it reaches to 1s3, basically this is going to actuate this directional control valve. air will pass through this line, right? And it gets inside this line, and from there air gets to this throttle check valve, right? And it should decide which way it can go through this basically time delay valve. If it comes to this point, first it checks this side, right? This side of check valve, and it's basically cannot pass through that way because there is a ball, right? And that ball will be pushed by the air towards this corner, and that is going to be blocked and the air cannot pass, and it will look at this throttle check valve. Depending on how much opening that we have in here and depending on capacity of this reservoir, we can have a certain amount of delay within the system, right? And once we have the air completely like this reservoir with the full capacity of the air coming from this side, right, we are basically passing that time delay valve, and from there air will pass through this pneumatic actuation, right? And this is going to be pneumatically actuated, and the directional control valve will shift to the second position, which is an open position, right? And the air can pass through this arrow and this line, and from there we will have 1v3 actuated. And once this is actuated, basically this directional control valve will return to its initial position. Now let's look, if I start this push button, what will happen? If I start this push button, right, you see it reaches to that position, and now the air is passing here, right, until we have this reservoir completely filled, right? Once it is in the full capacity, it passes the air to this pneumatic actuation, and the system will basically, as I said, this directional control valve will pass the air to this pneumatic actuation, and it will basically shift the direction of double acting cylinder, and it will return back to its initial position. This is how a time delay valve can help us to have a certain amount of delay for an operation within a pneumatic circuit. So you can think about different applications, right? We can have, let's say, an automatic door when it is basically, let's say we have push buttons from both sides, and once we push that button, the door is going to be open, right? And it reaches to the fully open condition, but it should stay there for a few seconds, because if it returns back immediately to the closed condition, right, we cannot pass through that door safely. So we need to have a sort of time delay valve. Generally, this system of automatic door is a sort of electro-pneumatic system, but we can design an automatic door with the use of just pneumatic system. Okay, so in the next video I'm going to look at basically quick exhaust valve, how a quick exhaust valve works inside pneumatic circuit, and after that basically lab session I will focus on a few different applications of pneumatic system, industrial application of pneumatic system. Probably I would have 2-3 videos on industrial application of pneumatic system, and we will completely look at the applications inside FluidSIM, design different circuits, and once we are done with those applications we will jump to electro-pneumatic circuits. Thank you very much for watching this video, and hope you learned about time delay valve. If you learned how time delay valve works, how we can basically implement them inside pneumatic circuits, and how we can design pneumatic circuits with time delay valve inside FluidSIM, please subscribe our channel.